So okay, so you need to be really giving in your best at this point. इस चीज के लिए तुम last 2 साल 2.5 साल से prepare कर रहे थे, right? So please do not slack now. Give in your best, and what do you have to do is still the same, right? You have to take mock tests, you have to revise notes, you have to invest more time in slightly difficult problems, slightly more conceptual problems. Mains ka test taking, in fact any other exam ka test taking or advanced ka test taking में, that is there's just one basic difference. Advanced के problems को you must have that patience to solve the problems of advanced, like, right? वो ठहर के रुक के प्रॉब्लम सॉल्व करना होता है. यू कैन नॉट बी जस्ट सॉल्विंग इट ऑन द फ्लो, राइट? कि हाँ ये क्वेश्चन हुआ, नेक्स्ट क्वेश्चन, थर्ड क्वेश्चन, राइट, टक टक टक. दैट इज नॉट हाउ एडवांस इज डन. You will have to just learn how to be patient enough, stay with the problem for some time, 2 3 4 5 minutes, and then you'll be able to solve the problem. People generally are so used to taking mains paper कि वो advanced वाले question देख के ही psych out हो जाते हैं. So that is not how you have to take the advanced paper, right? You'll have to learn to stay with the problem for a while, think on it and solve. Not that they are difficult, थोड़ा सा lengthy sort of problem होता है, right? Same concepts, but more number of concepts in one problem. Okay. That is how it is. So let's see, and do not expect कि किए हुए problems आएंगे advanced में. Advanced में they don't give you standard problems. In mains, in all other exams, they give standard problems. In advanced, they are still trying to maintain the level. In JEE Advanced, they give you good problems. They give you fresh problems. Okay. So that is these are the two things in mind that you have to keep in mind. पहला चीज रुक के करने का आदत डालना होगा प्रॉब्लम को, ठहर के करने का. और दूसरा चीज कोई नया कुछ प्रॉब्लम, नया कुछ you must be okay with dealing with a new type of a problem, right? Obviously the concepts will remain the same, but the problem setup can be new, right? So JEE Advanced का last 10 साल का paper, maybe you can use them as mock tests, right? They'll be the best mock tests that you can get for JEE Advanced. Okay. Fine. Let's start off. We'll try to discuss some new ideas. Let's see how well you can still absorb new ideas. I'll share the whiteboard. Let's start. Okay. So let's assume that there is a charged sphere, and the charge on the sphere is sigma equals to sigma naught cos theta, let's say. So it's a hollow sphere with surface charge density as this. Hollow sphere with surface charge density as this. And so if I ask you what is the electric field at the center, what would you answer? What is the electric field at the center of this sphere? I hope you understand the charge configuration. कैसा charge configuration होगा इसमें?
एक side positive or एक side negative.
Theta, yeah. One side will have positive values, the other side you would have negative values. Yeah, that's correct. If I assume that this is the angle theta, right? This is the angle theta. So maximum positive charge यहाँ पे होगा where theta is 0, and then the charge density will decrease as we move away. यहाँ पर theta is negative, so negative value maybe cos theta would be positive. If you are able to visualize, and on the lower lower half of the hemisphere, lower half of the sphere, you'll have negative charges, and then the negative charges will gradually increase in density and so on. This is the charge configuration, right? Electric field at the center. क्या direction में होगा? That is guessable. The direction of the electric field
Downward.
should be downwards. Please calculate the value. If you know the result, final result, you can tell that as well. If you cannot remember it.
Sigma by 2 epsilon naught R.
Anyone else getting any other answer?
Sir, एक
Sorry. Checker, Archit, question paper. Mistake here, right?
K sigma naught by R.
K sigma not by R. So please check. K solve K. How to solve this?
Sir,
Sorry,
differential
Sir,
element
sigma
here.
by 3 epsilon.
sigma by 3 epsilon. Yes, good idea. How to solve this?
एंगल दी थीटा पे एलिमेंट लेके इंटीग्रेट करना
Differential rings लेके integrate करना होगा, right? That is one way. Differential ring at an angle theta, if I take a differential ring, तब इस ring के कारण electric field अपन बोल सकते हैं कि downwards होगा, right? And so for this differential ring, we can say that the radius of this ring will be r, क्या आएगा ये? R sin theta,
r sin theta.
and the width of this ring can be written as r d theta. And so I can write down the charge on that ring as dq would be sigma naught cos theta into r sin theta
Two.
into r d theta, right? And so for this charge, I can find out the electric field at the center, and that will be k into dq by kqx. You know the formula, right? kqx by r square x square 3 by 2 x. यहाँ पर क्या होगा बताओ?
R हो जाएगा।
R.
r हो जाएगा।
ये R cos theta.
r cos theta होगा ना, ये वाला लेंथ होगा ना. This is the distance of the ring from the point जहाँ पर field निकालना. Okay, so k into q into r cos theta by r square plus x square, where r square is r square cos sin square theta, and x square is again r square cos square theta, power 3 by 2. Please go through. And this can be integrated from what to what should you integrate this?
So 0 to pi by 2.
0 to pi by
And
2.
we'll double.
0 to pi.
हाँ ठीक है, 0 to pi by 2 करके डबल कर दो या फिर एक ही बात है, right? E resultant can be either written as integral of dE 0 to pi या pi by 2 या फिर directly 0 to pi integrate कर दो, एक ही बात है. Okay, so the result that you will get is sigma by sigma naught by 3 epsilon naught. Go through it, please. But I was not interested in, I'm not interested in this. This is a standard method, of course. But मैं ये problem क्यों put across किया? I know you guys can do this integration. Not for this integration I've given the problem. Let's understand ये problem में क्यों put across किया. A very important and a very subtle way to approach problems with this kind of a charge distribution is as follows. ठीक है, इस टाइप का अगर चार्ज डिस्ट्रीब्यूशन दिया हुआ है सिग्मा नॉट कॉस थीटा, देन इलेक्ट्रिक फील्ड निकालने के लिए या तो ऐसा रिंग्स विंग्स लेके इंटीग्रेट कर सकते हैं, या फिर व्हाट आई कैन डू इज आई कैन थिंक ऑफ टू यूनिफॉर्मली चार्ज स्फीयर्स and they are separated by a small distance. Two uniformly charged spheres, and I just एक पॉजिटिव स्फीयर को थोड़ा सा ऊपर शिफ्ट कर दिया और नेगेटिव स्फीयर को थोड़ा सा नीचे शिफ्ट कर दिया. Are you able to visualize? So इस रीजन में तो चार्ज कैंसिल ऑफ हो जाएगा. This is the plus rho sphere or plus rho naught sphere, whatever you call it as, and this is the minus rho naught sphere. I'm assuming two charge distributions, a positive charge distribution and a negative charge distribution. In this region, the positive and the negative charges will just cancel off each other. See if you're clear with this. The common region में positive and negative charges will cancel off, right? And you will only have positive charge on the upper, वो जो moon shaped, crescent shaped, thing, and a negative charge on the lower crescent shaped moon. Are you able to visualize this? Yes or no?
Yes, sir.
So if I assume that the two spheres have been separated by a distance d from each other, or delta from each other, whatever you name the term. Now, please realize if I look at this point, if I look at an angle theta, then what will be the charge in this much region? Can you tell me? Charge in this much region कितना होगा? डेल्टा क्यू कितना होगा? प्रॉब्लम समझ में आया क्या? पहले ये मैं दोनों स्फीयर्स को I take a positively charged sphere of rho naught and a negatively charged sphere of minus rho naught, and instead of completely superimposing them, I just keep them delta distance apart from each other. This distance is d or delta, whatever you call it as d. Okay, so now what is the charge in this much region? The charge in this much region can be written as area. अगर इसका a assume करते हैं delta a, if I assume that the area of that region is, the cross section area is delta a, then I can write down delta a into d cos theta. Yes or no? ये अगर d है तो ये length d cos theta आएगा. And this is the volume, and into the charge density, that is rho naught. And so sigma over there now, अपने जो sigma को define किए, that is charge by area. Sigma that we have defined is charge by area. What do we get this as? We get this as rho naught d cos theta. And so this rho naught d will serve as what?
Sigma naught.
Yes, this is sigma. This is sigma naught. देखो समझ में आ रहा है. It's a very important way to look at a charge configuration with sigma naught cos theta. इसका और कुछ एक application maybe we can check too. Are we clear with this?
Yes, sir.
और एक बार ये चीज इंश्योर हो गया कि these are two uniformly charged non-conducting spheres का overlap, then electric field निकालना तो बहुत आसान है. Why? Because this is like a common region, और common region में electric field का क्या formula होता था?
Rho by 3 epsilon naught into d.
बस rho r by 3 epsilon naught होता था. है ना? If I assume that there are two spheres, a positively charged sphere and a negatively charged sphere, then in the overlap region I can say that the electric field is uniform, etc. If you are able to recollect this, the direction of the electric field is from the center of the positive sphere to the center of the negative sphere. This is C plus, this is C minus, तो ये डिस्टेंस अगर a पता है या जो भी पता है, the electric field in this common region can be written as rho a by 3 epsilon. Please go through this. The electric field is uniform, rho vector a by 3 epsilon. I hope इसका derivation तुम लोगों को याद है. Positive sphere का rho r plus by 3 epsilon naught, then plus of rho r minus by 3 epsilon naught, r plus r minus will give you vector a and so on. Okay, so I have to find out the electric field at the center now. Can you find that? The resultant electric
ये तो
field.
कांस्टेंट रीजन हो गया ना, फिर हर जगह ही सेम हो गया.
हर जगह ही
लाइक इलेक्ट्रिक फील्ड हर जगह सेम हो जाएगा इससे तो.
नहीं, अपने को सिर्फ सेंटर पे इलेक्ट्रिक फील्ड निकालना है. ओके, वी आर जस्ट इंटरेस्टेड इन द इलेक्ट्रिक फील्ड एट द सेंटर ऑफ दिस फ्लो. आई एम ओनली इंटरेस्टेड इन द इलेक्ट्रिक फील्ड एट द सेंटर ऑफ दिस सिस्टम. So that will be given as what? That will be given as rho naught into the distance will be d by 3 epsilon naught, and rho naught into d is what? Rho naught into d is your sigma naught. So that is sigma naught by 3 epsilon naught. The idea is कि इतना लंबा इंटीग्रेशन वगैरह नहीं करके you can just use this as a technique to solve problems on distribution sigma naught cos theta. Please go through it. If you have any doubts, please ask. Okay. अब इसी कॉन्फ़िगरेशन के लिए if I ask you what is the electric dipole moment, there will be some dipole moment offered by this. How much is the electric dipole moment of this system? That will be my second question. Find the dipole moment due to this charge distribution. I hope I'm clear with the question. There are two, there's a charge distribution sigma equals to sigma naught cos theta. And you have to find out the electric dipole moment for this. ऊपर में you have a set of
sigma
positive
naught into
charges.
volume हो गया of the sphere.
And lower half में you have negative charges. So what did we do over here? We assumed two spheres, two uniformly charged sphere, a positive sphere and a negative sphere, and we separated them by a distance d, right? A positive sphere and a negative sphere, we separated them by distance d. So this is the center of the positive sphere, and this would be the center of the negative sphere. And if I concentrate the charge at the center of these spheres, then I can say that the dipole moment will be from where to where?
Negative to positive.
ऐसा कुछ dipole moment आना चाहिए, right? And so dipole moment can be written as q into d, where q is how much? Q will be 4 by 3
Rho naught into
pi r cube into rho naught into d. You get that? एक प्लस रो स्फीयर है, दूसरा माइनस रो स्फीयर है, तो दोनों का चार्ज को सेंटर पे कंसंट्रेट करके एटसेट्रा, सेम ओल्ड थिंग्स. And so now 4 by 3 pi r cube, rho naught into d can be written as what? Rho naught into d can be replaced as sigma naught, and so I can write it as 4 by 3 pi r cube sigma naught. That's the dipole. Okay, that was the problem. There's a sphere, there's some non-conducting sphere of radius r, hollow sphere of radius r, and the charge distribution is sigma naught cos theta. What is the dipole moment that it offers? This is the answer. Clear?
Yes, sir.
सर
हाँ बोलो।
सर तो ये डबल स्पीयर वाला अगर आइडिया स्ट्रक नहीं किया तो फिर
अरे
कैसे
यार,
करेंगे?
वही तो मैं बोल रहा हूँ कि ये वाला आइडिया स्ट्रक नहीं करता है। ये वाला आइडिया पहले से याद होना चाहिए। Physics में if you go for masters, maybe if you go for physics, if you take physics at masters level or so, then there are standard structures कि ये वाला problem को इस तरह से approach करना है। मतलब it will become more like maths। जैसे अभी तुम लोग के maths है +2 level पे, physics will also become more like maths। There are standard structures, and if you go by that standard structure, you'll be able to solve the problem. Otherwise, okay, physics remains very conceptual up till class 12 and this JEE level, but once you go for masters या bachelors in physics, then it becomes एकदम structured type हो जाता है, which is a bad thing. I mean, physics should not have been that way, but then that is how it becomes. So this is a standard way to solve questions of this type. Fine. Now if I ask you another question, suppose there is a uniform electric field. कोई capacitor ले लो, parallel plate capacitor, uniform electric field वो produce किया. For that capacitor, inside that capacitor, I place a conducting sphere. What will be the charge distribution on this conducting sphere? If you can tell me. This is, let's go. ऐसा मान लो. It's a uniform electric field. मैं dielectric से कर लिया. Normally भी I can just take a uniform electric field, and there is a conducting sphere. How does the electric field lines look like over here? Do we know that? This we know, right?
Yes, sir.
ये तो standard
Positive and negative.
past year JEE question type ही है. तो the electric field lines will terminate perpendicular to the surface and so on. यहाँ पर electric field lines ऐसा रहेगा. But as it comes towards the conductor, that will bend a bit. Why? Because charges induce होगा. यहाँ पे कैसा charge induce होगा?
Negative.
यहाँ पर कुछ negative charge induce होगा. इधर पे सबसे ज़्यादा negative charge, फिर वापस से कम. I hope you are understanding what I'm trying to approach towards. यहाँ पर positive charge induce होगा. इधर पे सबसे ज़्यादा, इधर पे कम, right? So the electric field line diagram will look like this. Sorry. Something like this. This is past year JEE question type. ठीक है ना? स्टैंडर्ड ये JEE क्वेश्चन है कि अगर एक कंडक्टर रख दिए तो इलेक्ट्रिक फील्ड लाइन कैसा डिस्टॉर्ट हो जाएगा. If I ask you what is the charge distribution inside, then what would you answer? What is the charge induced? This should be sigma naught cos theta. Why? Why should this be sigma naught cos theta? Because this will lead to the production of a uniform electric field inside. And this uniform electric field and the external field will what?
Cancel.
Will cancel off, so
Cancel
that the
out.
resultant
Cancel out.
electric field inside the conductor remains. That is the rule of a conductor. Resultant field, electrostatic condition में resultant electric field inside a conductor is zero. तो जीरो होने के लिए यहाँ पे मेरे को यूनिफॉर्म इलेक्ट्रिक फील्ड प्रोड्यूस करना है. ऑपोजिट चार्जेस इंड्यूस हो रहा है, यूनिफॉर्म इलेक्ट्रिक फील्ड चाहिए. सब कंडीशन मैच कर रहे हैं ना. Okay, and so I can say that the charge induced on this sphere, we already have a formula for the electric field produced. The electric field produced is rho naught d by 3 epsilon naught, which can be written as sigma naught by 3 epsilon naught. So sigma naught by 3 epsilon naught will be equals to E. And so I get sigma naught as 3 epsilon naught E naught. And so the charge induced can be written as 3 epsilon naught E naught cos theta. Please go. Clear है?
Yeah.
तो अब अगर मेरे को रिजल्टेंट इलेक्ट्रिक फील्ड बाहर में भी निकालना है तो वो भी अपन निकाल सकते हैं, बिकॉज आई नो द चार्ज डिस्ट्रीब्यूशन ऑफ दिस कंडक्टिंग स्फीयर. रिजल्टेंट इलेक्ट्रिक फील्ड एनीवेयर अराउंड कैन बी फाउंड. इट विल बी अ सुपरपोजिशन ऑफ E नॉट अपवर्ड्स, और इस चार्ज डिस्ट्रीब्यूशन के कारण, और इस चार्ज डिस्ट्रीब्यूशन को एक डाइपोल मोमेंट मान सकते हैं. तो डाइपोल मोमेंट का तो इलेक्ट्रिक फील्ड का स्टैंडर्ड फॉर्मूला है, दैट यू नो. व्हाट आर द फॉर्मूलास? ER and E theta. I hope you know that.
Yes.
P by R cube and KP
क्या?
by
ER का
2 KP R 2 KP cos theta by R
हाँ,
cube.
cos theta sin theta रहेगा ना. There will be cos theta sin theta, right? This was 2 KP cos theta. This is, I think, KP sin theta by R cube.
Yes.
Okay. So R cap and theta cap. So this electric field can be found by the idea that we discussed in 2. And an external electric field, you know, is तीनों का superposition will give you the electric field at any point outside. Fine. Let's move forward. समझ में आई ये चीज? If you have doubts, please ask.
Yes, sir.
Okay. So okay. So if I assume that in the region there is an electric field given by the formula K into xi cap plus yj cap plus zk cap. You have to find me out the charge distribution, the charge density in that field. How do you find this out? Yes. Can be done. क्या फॉर्मूला यूज करेंगे ये दो निकालने के लिए?
3K epsilon naught.
कैसे निकालेंगे? देखो
फ्लक्स लेके ओरिजिन से करके एक उसमें क्यूब में फ्लक्स निकालेंगे.
क्यूब में फ्लक्स
हाँ.
निकालेंगे.
मतलब क्यूब का वो सरफेस से.
क्यूब का सरफेस पे तो फ्लक्स निकालना थोड़ा मुश्किल लग रहा है मुझे यार. कैसे
नहीं
निकालें?
सर, अलोंग.
How do you find out this flux at the
Sir,
surface of a cube?
अगर y is equals to a पे कुछ है, कोई एक सरफेस है,
हाँ.
तो उधर तो उसे y कांस्टेंट रहेगा और x और z तो पैरेलल टू द सरफेस हो जाएगा, तो जीरो हो जाएगा उसका फ्लक्स.
Can you share what you solved? Yeah, if you can send me the pic over here, मतलब WhatsApp पे. फ्लक्स कैसे निकाला मैं वही देखना चाह रहा था.
तो मेरा
अच्छा, ये
कहने का
सेइंग
मतलब है
कि
कि
कोई भी अगर एक क्यूब
x
लेगा तो ओके ये सेइंग
जाएगा तो वो तो जीरो हो जाएगा, तो वेरिएबल कुछ भी नहीं रहा.
तो फ्लक्स निकल जाएगा उस सरफेस पे.
हाँ, इजी निकल
ओके,
जाएगा.
let's check your way also. So if I assume that there's a cube which is x equals to maybe a, this is x equals to 0, this is y equal to 0, this is y equals to a, and this is z equals to 0. This is xz plane. Sorry, this is yz
सर
plane. So
origin
this
ले
is
लेते हैं.
ये origin है. This is the origin. This is the origin. Right. So this is y equals to a. This is x equals to a. This is x equals to 0. Okay. So this is the surface y equals to 0. This is the surface y equals to a, and the one behind is the surface z equals to 0, and ये वाला will be the surface z equals to a. Everyone, are you clear with this?
Yes.
Okay. So for the surface, if I just number the surfaces, 1, 2, the red ones are, let's say, 3 and 4, and the blue ones are 5 and 6. This is 5, and the one behind is 6. So now I can say that for the surface 1, what will be the electric flux? The electric flux should be 0 because x is 0. Only the horizontal component of the electric field would have produced a flux for the surface 1, and so the flux for the surface 1 is 0. Flux for the surface 2 will be how much? The electric field for the surface 2 is k into a.
Sir, K cube.
So k into a squared will be k cube. Yes, very good. The flux of the surface 3 will be k cube again, I think. Why? Because y is a over here, and the y component of the electric field is effectively what is producing flux at that surface, and so that will be k into a square, so k cube again. 5 4 will be 0 because वहाँ पर y coordinate is 0 है. Then 5 5 के लिए you will again get k cube, and 5 6 will be 0, and so I get the net flux as 3 k cube. Okay. And so flux can be written as q by epsilon naught, and q can be written as charge density into the volume. So rho into a cube by epsilon naught is 3k a cube, and so a cubes are gone. I get the charge density as 3k epsilon. Very good.
Yes.
Okay. या फिर अभी क्या कर सकते हैं? I can assume that the electric field can be written as k into vector r. Okay. वाला method नहीं करके let's try this method. We know that Gauss law says integral e dot ds is q enclosed by epsilon naught, right? And if I take a very small element in a region, if I take a very small element in a region of charge distribution, let's say of distances dx, dy, and dz, then I can write down charge density as rho into dx dy dz, right? जो यहाँ पर किया उसका मैं एक जनरल रिजल्ट निकालने की कोशिश कर रहा हूँ, and divided by epsilon naught. LHS में क्या लिख सकते हैं बताओ? LHS में we can say कि अगर इस सरफेस पे इलेक्ट्रिक फ्लक्स फील्ड E है, तो इस सरफेस पे E प्लस DEX होगा. यहाँ पर अगर EX है तो यहाँ पे EX प्लस DEX होगा.
Yes, sir.
Okay. And so what will be the net flux? The net flux can be written as DEX into this area, and this area will be how much? dy dz.
Yeah.
So I can say that this will be DEX into dy dz. देखो ये समझ में आया या नहीं? On the
Yes, sir.
left surface, you have entering flux, and so that will be negative. On the right surface, you have emerging flux, and so that will be positive. But the electric field would have slightly increased, so more positive flux and less negative flux. यहाँ पर E into S है, यहाँ पर E plus DE into S है. So the effective flux is dE into S. That is what I'm writing. And this dE is along the x-axis and the area is dy dz. There'll be similar terms, right? What will be the similar terms for the electric field in the y direction? यहाँ पर EY अगर है इस सरफेस पे और ऊपर वाले सरफेस पे EY plus DEY है, then what can you write it as?
Sir, dy
dy into
dy
dx.
into dx dz. Yes,
D-
very good. Dey into dz dx dz. And similarly, there will be another term. The other term would be for the surface behind and the surface in front. यहाँ पर अगर Ez है तो यहाँ पर होगा Ez plus dz, Ez plus dz, and so the extra flux emerging will be written as dz into what? Dz into dx dy. See if you're clear with this. And so what is the general result that we get out of it? We can say that dex by dx plus dey by dy plus dez by dz is equals to what? Is equals to rho by epsilon. This is the equation which I want you to remember. In fact, this is known as a Nabla operator. Dou x I. This is del dot E. Del dot E is rho by epsilon naught. Gauss law को ऐसा भी express किया जा सकता है. Del dot E is equals to rho by epsilon. This delta operator or Nabla operator, as you may call, is I cap dou x plus j cap dou y plus k cap dou z. This is what is this delta operator. तो अगर del dot E करेंगे तो क्या बचेगा? मतलब E is Ex, I cap, Ey, J cap, Ez, K cap. तो del dot E अगर करेंगे तो I'll just be left with those terms LHS में जो अपन लिखे. So you can just remember that. Go through it, please. This is what I want you to remember. ये वाला फॉर्म शो ऑफ करने के लिए याद रख सकते हो, बट उतना सा later on in engineering first year you'll be introduced to this form. So this is the equation. तो यहाँ पर ये वाला इक्वेशन अगर यूज करोगे तो भी आ जाएगा आंसर. ये सब फ्लक्स वगैरह कैलकुलेट करने का कोई झमेला नहीं है, डायरेक्टली आंसर आ जाएगा. प्लीज गो थ्रू इट. Okay. Any other way in which you can approach? ये तो एक मेथड हो गया सॉल्व करने का प्रॉब्लम. ये दूसरा मेथड हो गया सॉल्व करने का. ये डायरेक्ट फॉर्मूला एप्लीकेशन हो गया, राइट? This will be 3k is equals to rho by epsilon naught, so 3k epsilon naught will be the answer. Any other method that you can think of, maybe?
सर
Mhm.
सर ये क्यूब लेकर तो मतलब इसमें रो कांस्टेंट था, बट अगर रो एज अ फंक्शन ऑफ आर आ जाता तो ये क्यूब लेकर होता क्या?
उस केस में फिर ये वाला फॉर्मूला ज्यादा काम आता है चार्ज डेंसिटी निकालने के लिए.
ओके सर.
I
तीसरा
could have assumed
मेथड
a sphere. एक sphere लेके अगर आगे बढ़े तो इलेक्ट्रिक फील्ड इज k into vector r. xi का y cap z cap है, तो this should also be a natural way to look at it. So if I assume a sphere of radius r and then another sphere of radius r plus dr maybe, right? तो इस रीजन में क्या चार्ज डेंसिटी है अगर रो अज्यूम करते हैं?
रो इनटू 4 पाई
Right, rho into 4 pi r squared dr will be the total charge enclosed. Okay. So instead of writing those many terms, dx by dx plus dy by dy, dz by dz, what else I could have done?
सर इसमें तो डायरेक्टली वो नहीं हो जाएगा
क्या?
सब इसमें डायरेक्टली तो इंटीग्रेशन कर सकते हो के आर हो
डायरेक्ट
गया
इंटीग्रेशन कर सकते हैं, है ना? क्या आएगा बताओ?
तो के into 4
E into
r
yes,
square 4
E
pi
into
r
4 pi
cubes.
r square is the entering flux, and E plus dE into 4 pi r squared would be the emerging flux. ऐसा Gaussian surface लिया मैं, right? I've just taken a Gaussian surface like this, right? This is a Gaussian surface, you can say. This is a region that I've taken. तो यहाँ पर कुछ entering flux हुआ और फिर कुछ emerging flux हुआ. So what is the net flux linked? वो निकाल दो. This is the entering flux and this is the emerging flux. The emerging flux will be greater, yeah, maybe less because the electric field would have decreased. I don't know. We do not know. We're just assuming one thing: कि emerging flux ज़्यादा है than entering flux. If you're wrong, D will be negative. बस और कुछ नहीं. And that can be written as what? Charge enclosed कितना होगा उस region में?
Rho into 4 pi r squared dr.
Rho into 4 pi r squared dr, volume of that shaded part by epsilon naught. So 4 pi r square I think will cancel off dE by r squared dr is rho by epsilon. ठीक है, देखो क्या आंसर आ रहा है.
तो r square क्यों होगा
तो नहीं, आज का तो कैंसिल ऑफ हो गया सर. Yeah, dou E by dou R is rho by epsilon.
ऐसा तो सिर्फ k एप्सिलॉन लगा है
Electric field at E into 4 pi r squared is rho into 4 pi r squared dr. They do some calculation errors here.
ऐसा लग नहीं रहा कि हर जगह 4 pi r square ही आना चाहिए
4 pi r squared cancel off हो जा रहा है. Rho by epsilon. ये area of the surface would also have increased, no? तो area को a plus delta a लिखना होगा. This area is not, the area also would have increased. So it is like minus of E into S plus of E plus D, the increment in the electric field, into the increment in the area S plus ds, है ना? तो फिर वो जो difference आएगा, that will give you the answer. This is not exactly 4 pi r square. बाहर वाला surface will be थोड़ा सा ज़्यादा area, and so you'll have to consider that. ये जो D into ds वाला term है, that we can ignore. But E into ds वाला एक term आएगा which we cannot ignore. Are you getting the idea? There'll be 4 terms, right? E into S plus E into ds plus S into dE plus D into ds. So ये वाला term we can ignore. Okay. but यहाँ पर we just considered E into D into S वाला term. D into S वाला term we considered, but we did not consider this term. So this term should also be there. Go through it, please. ये minus ES और plus ES तो cancel off हो जाएगा. This term we ignored, and this will be rho into 4 pi r squared by जो भी है. So this is another way. Okay. Fine. Let's move forward. Next question is that. Suppose if I ask you this question. ये image method थोड़ा सा details में I wanted to discuss today. For conducting spheres specifically. ध्यान दो please. So if I, let's say, assume that there are multiple charges in a region. Q1, Q2, Q3, Q4, and Q5. Now, there might be a equipotential surface which might be of this shape. अलग-अलग equipotential surface आएगा due to these 5 charges. Yes.
Yes, sir.
तो मैं अगर assume किया that this is one of the equipotential surface with potential V naught. One equipotential surface with V equals to V naught. Then the idea is that if I replace the two charges Q4 and Q5, right, by a conductor is also an equipotential. Okay, this is a equipotential surface. This is not a conductor as of now. As of now, we just have 5 charges in this region. There is a resultant electric field produced by the 5 charges, and there will be various equipotential surfaces, right? यहाँ पर कुछ ऐसा equipotential surface होगा, फिर दोनों को mix करता हुआ equipotential surface होगा, और फिर ऐसा कुछ equipotential surface होगा, some things like that, right? So one of the equipotential surface is this, and let's say its potential is V naught. What this idea says is that if I keep the charges 1, 2, 3 intact, and I replace this entire region with a conductor of exactly the same shape and exactly the same charge, then the outer region will not know about it. एक अगर कंडक्टर में प्लेस कर दिया यहाँ पर, assume कर लो कि ये जो मैं शेप बनाया वो यही शेप है, exactly of the same shape, and charge on the conductor में Q4 plus Q5 दे दिया, then the system is equivalent. The system is then equivalent. See if you are able to digest this idea. Conductor है तो उसका potential सब जगह constant होगा. Potential of the conductor at all the points on the surface will be constant, and that one constant potential can be V naught. For example, suppose there is a charge Q. Then how does the electric field look like for a charge Q? Radial lines. Yes or no? And the electric
Yes,
field
sir.
at any distance R can be written by what formula? KQ by R square. Okay. Now, this idea says that if I replace this charged particle with a charged conductor, and what should be the size of this charged conductor? कोई भी एक equipotential surface ले लो. यहाँ पर equipotential surfaces are the spheres. So if I replace the charge inside this equipotential surface, and I put a conductor here, of what radius? If I assume that the equipotential surface I've taken is of radius r, it's a sphere of radius r, then एक ही बात रहेगा ना, I can replace the charged particle by a charged conductor, What should be the charge on that conductor?
Q.
A Q.
Q. And what should be the radius of that conductor, R? And we can say that the electric field outside does not care. The electric field outside will remain the same. Yes or no? यहाँ पर भी electric field KQ by R squared है.
Yes, sir.
See if you are clear with this idea. If you have doubts, please
Sir.
ask. Yes, please.
सर बट कंडक्टर के अंदर से इलेक्ट्रिक फील्ड जीरो हो
अंदर
जाएगा
से-
जैसे पहला केस।
हाँ हाँ, अंदर का बात का से अपने को मतलब नहीं. I am only interested in the in what is happening outside of this region. Outside of this region will not know what has happened over here. यहाँ पर दो चार्ज पार्टिकल को मैं कंडक्टर से रिप्लेस कर दिया जिसका साइज एग्जैक्टली एक कोई इक्विपोटेंशियल सरफेस जैसा है, तो ऐसा कर सकते.
ओके सर.
The region outside will not know about what we have done in over here. The region outside will remain exactly the same. That is what I want to tell. ठीक है, बाहर वालों को पता नहीं चलेगा कि हमने अंदर में क्या काम किया. See if you are clear with this.
Yes.
बहुत बढ़िया बात है. तो अब इस आइडिया को यूज करते हैं. Let's assume that there are two charged particles Q1 and Q2. एक नया प्रॉब्लम ले रहा हूँ और फिर we'll try to connect the dots. There are two charged particles. एक चार्ज Q1 assume कर लो और एक चार्ज Q2 assume कर लो, which is at a distance minus Q2 assume कर लेते हैं, which is maybe at a distance d from this charge particle. Now, do you agree that there will be some zero potential region आसपास में कहीं पर?
Sir,
Yes, sir.
जहाँ पर potential of the positive charge and the potential of the negative charge cancels off each other and you'll have a zero potential. Yes. So if I take any point P, x comma y comma z, what can you write down the potential of that point as? Please tell me. Tell us the potential is point पर. Potential of that point P can be written as k into q1 by x square plus y squared plus z squared plus k into minus q2.
sir, root होगा.
Of course, there'll be a root to the path half. Thank you. ये सब चीज थोड़ा सा check करते रहो. K into minus q2 in by यहाँ पे distance हो जाएगा x minus d, y squared z squared half. And I want this to be zero. I'm trying to find out a equipotential surface जिसका zero potential. Okay, that is the question. Suppose in this problem the question is find the equipotential surface का equation with zero potential. Do you get this?
Yes, sir.
तो अभी इसको थोड़ा सा please help me to simplify this. Try to frame a legitimate equation out of it. थोड़ा सा if you can do the math. I want you to do the math. ये चीज ही जरूरी है एडवांस में, थोड़ा सा रुक कर मे भी मैथ्स करने का. मेंस का क्वेश्चन अगर ये होता तो बस ये इक्वेशन लिखते ही आंसर आ जाता. बट अब you know in advance you'll have to just have the patience of simplifying it one or two more steps. That is the माने at grassroots level that is the difference. कोई कॉन्सेप्ट बहुत डिफिकल्ट नहीं होगा, वो थोड़ा सा रुक कर प्रैक्टिस सॉल्व करने का वो पेशेंस रखना होगा. प्लीज सॉल्व. I'll get a q1 squared into x minus d squared plus y squared plus z squared, and that be equals to q2 squared into x squared plus y squared plus z squared. Okay, and so I can further simplify this. कैसा आ रहा है?
x square plus y square plus z square into q2 square minus q1 square वैसे कर लेते
हाँ, एक x square z square y square z square कॉमन ले सकते हैं, q1 square minus q2 square. और क्या बच रहा है?
minus 2 dx q1 square
minus 2 dx q1 square. Okay,
plus
कुछ बच रहा है?
d square q1 square.
Plus d squared q1 square. These are the terms that we get. Please go through this. I can get rid of this q1 square minus q2 square इस तरह से. तो ये अगर ऑब्जर्व करो तो ये x minus a whole square वाला फॉर्म आ रहा है. Yes or no? This can be rewritten as x minus a whole squared plus y squared plus z squared equal to r squared.
हाँ सर.
Yes.
लिख पाओगे ना? जहाँ पर a और r का क्या वैल्यूज है? प्लीज टेल मी. What are the values for a and r? Come on.
So A is d q1 square by q1 square minus q2 square.
d q1 squared, yeah, thank you, d q1 squared by q1 squared minus q2 squared. Okay. Next, और r का क्या वैल्यू आ रहा है? प्लीज टेल मी. प्लीज सॉल्व एवरीवन, प्लीज सॉल्व एवरीवन. ये सॉल्व करने का आदत डालना होगा अगर एडवांस क्लियर करना है तो. यू नो दैट पेशेंस हैज टू बी डेवलप्ड. प्लीज सॉल्व फॉर r सॉल्व करना तो कोशिश करो.
सही इस इक्वेशन में
हम्म,
तो अगर हम लोग ओरिजिन वैसे मतलब कोई ले कि एक्स एक्सिस पे ही वाई जेड 0 कर दे तो फिर इजी हो जाएगा.
हाँ, मतलब ये वाला पॉइंट्स तो अपने आसानी से पा सकते हैं. ये सब ये पॉइंट्स जहाँ पर और ये वाला जो इक्विपोटेंशियल सरफेस है जो एक स्फीयर जैसा दिख रहा है मुझे, जैसे इक्वेशन ऑफ
हाँ.
स्फीयर, राइट? तो उसका जो पॉइंट्स इस पे आएगा वो तो आसानी से मिल सकते हैं. यस, दैट कैन बी डन. राइट आउट. सी इफ यू कैन फाइंड समथिंग. इस टाइप का कुछ इक्विपोटेंशियल सरफेस मुझे लग रहा है कि बनेगा, बिकॉज जो वैल्यू ए आया वो डी से बड़ा है. डी से बड़ा है. इट इज ग्रेटर देन डी. तो सेंटर जो होगा उसका x minus a square, right? This is the point a comma 0. This is the point d comma 0. Do you get that? The center of the sphere is to the right of the negative charge. The center of the equipotential surface with zero potential is to the right of the negative charge. ऐसा कुछ equipotential surface form.
Sir,
Yes.
so R is d q1 q2 by q1 square minus q2.
R is d q1 q2
D q1 q2
by q1
by
square
q1
minus
square minus q2.
q2 square. Someone, if you can please
Yes,
confirm.
sir. Yeah.
R is d q1 q2 by q1 square minus q2 square. Yeah.
Yes, sir.
So it is a sphere with this as the center, a comma 0, and and radius as d q1 q2 by q1 square minus q2 square. Very good. Thank you, Atna and Krish. D q1 q2 by q1 square minus q2 square. I'm assuming that what you've calculated is correct. Okay. अब क्या गेम हो गया यहाँ पर? यस, अभी जो कुछ देर पहले पढ़े उसको यहाँ पे फिट कर सकते हो क्या?
इस रेडियस का वो लगा सकते हैं Q2।
एक स्फीयर बना दो यहाँ पे। यस, रिप्लेस द चार्ज माइनस Q2 विद अ स्फीयर ऑफ रेडियस r एंड सेंटर्ड एट C, और उस स्फीयर पे कितना चार्ज डाल दो?
माइनस क्यू
माइनस Q2 चार्ज डाल दो, तो ये सेम रहने का है। The system will remain unchanged outside of this sphere, right? Outside of this sphere, the system will remain unchanged. So how can I use this in my problems? अब याद रखने के लिए please try to calculate r square by a. I think that will be a good answer to remember. Instead of remembering r, right? If you try to calculate r squared by a, क्या आ रहा है? R square by a will come out as Q1 squared, Q2 squared. Please calculate. This length, if I assume as b, okay, I'm assuming ये वाला length as b. How much is this length b? B can be written as a minus d. Okay, a minus d अगर मैं लिखता हूँ तो I'll get this expression as please mute yourself अगर कुछ बोलने का नहीं है।
Q2 square by Q1 square
d Q2 squared by Q1 squared minus Q2 squared. Yes, I'm assuming this is b. So if I do a r square by a now, क्या आ रहा है? please check करो. R square will be d Q1 square Q2
D.
square by इसका whole square आ जाएगा और divide by a
सर
करेंगे.
सेम वैल्यू है सर डी क्यू टू स्क्वायर बाई क्यू
We are getting it as b, right? Thank you. So this is an important result to remember. R squared by a is equals to b. R squared by a is equals to b. Where b is what? B is the distance between the center of the equipotential surface and the charge particle. ये एक important result है, याद रखने का. And can you find me out this charge Q2 का value in terms of R? Q2 का value निकाल सकते हो क्या?
In terms of
In terms of R, Q2 का वैल्यू इन टर्म्स ऑफ R डिवाइड करो ना, B और A को, B और R को अगर डिवाइड करेंगे तो मेरे ख्याल से बाकी सब टर्म्स कैंसिल हो जाएगा. Q1 square minus Q2 square वाला टर्म will cancel off, D will cancel off, a Q2 term will cancel off, so we'll be left with Q2 by 1, Q2 by Q1 as B by R, is it? Solve करो please, solve करो, come on. Q2 by Q1. Q2 by Q1 का वैल्यू मुझे चाहिए, so if I this will R by A से वो आ जाएगा मेरे ख्याल से. If you divide R and A, you'll get that.
सर आर स्क्वायर बाई ए स्क्वायर
ठीक है ना? If you divide R by A, all the other terms would cancel off. Q2 by Q1 बच जाएगा बस. So what is the equation that I get? I get Q2 as what? R by A into Q1. If someone can check. मैं कुछ गलती किया हूँ तो please if you can point out.
तो यही आया.
Yes, sir.
same.
तो ये दो बहुत इंपॉर्टेंट रिजल्ट्स आ गए. क्या रिजल्ट्स आ गए? अगर एक ग्राउंडेड कंडक्टिंग स्फीयर है और उसके पास में चार्ज Q1 रख दे तो कितना चार्ज उस कंडक्टर पे इंड्यूस होगा उसका फॉर्मूला मुझे पता चल गया. How will I use it in my problems? वो समझो. Suppose if I assume that there is a charge Q1 and there is a conducting sphere which is placed in the vicinity and the conducting sphere is grounded. Then what is the charge induced? The sphere is of radius r. The conducting sphere of radius r is grounded and it is in the vicinity of this charge Q1. Then what things can you identify? You can find out and ये वाला distance दिया हुआ है, suppose this distance is given. ये वाला distance d या b कुछ भी दिया हुआ है, a whatever it is. What all things can you find out? You can find out what is the distance b and what is the charge q. देखो समझ में आ रहा है या नहीं? b का value can be written as r squared by a and q2 का value can be written as r by a into q1, r by a into q1. Yes or no?
Yes, sir.
So a problem of this manner can be solved as what? Can be solved as, अब यहाँ पे कहीं भी इलेक्ट्रिक फील्ड पूछ लिया, what is the resultant electric field? या फिर what is the charge induced? ये भी पूछ सकते हैं, right? कुछ भी अगर इस प्रॉब्लम में कुछ भी अगर पूछा तो how would you solve this problem? I would solve this problem as a problem of two charges Q1 and minus Q2. And where is that minus Q2 placed? At a distance b from the center. बस हो गया. It is a two charge particle का problem. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
तो इसका अगर मैं और कंडक्टर के जस्ट बाहर में इलेक्ट्रिक फील्ड कितना होता है वो तो हमें पता ही है. जस्ट
Sigma by 2.
मतलब if you have to find out the charge density there or if you know the charge density there, the resultant charge density जो भी induce हुआ etc सब मिला के the resultant electric field will be sigma by epsilon. The resultant electric field will be sigma by epsilon out there. देखो समझ में आ रहा है?
सर
Yes.
तो वो जो हम लोग जो Q2 निकाले वो तो हम लोग ऐसे भी निकाल सकते थे अगर स्फीयर दिया होता तो.
Q2 निकाले,
वो हम लोग
हाँ वो तो पोटेंशियल जीरो
Q2
करके निकालना है.
हाँ.
पोटेंशियल जीरो करना है ना, पोटेंशियल जीरो करना है. इस पॉइंट पे पोटेंशियल जीरो हो रहा है ना, इस पॉइंट पे पोटेंशियल जीरो हो रहा है तो ये पॉइंट पे पोटेंशियल एक का पोटेंशियल और दूसरा का पोटेंशियल इक्वल टू जीरो करके भी वो आ सकता था Q2 का वैल्यू.
नहीं अगर स्फीयर दिया हुआ है तो फिर वो तो हम लोग स्फीयर के सेंटर पे ही करते हैं जनरली.
स्फीयर के सेंटर पे, हाँ स्फीयर के सेंटर पे यू कैन फाइंड आउट द पोटेंशियल.
वो भी जीरो होगा अगर
Yes, yes.
स्फीयर है तो.
यस यस यस, कंडक्टर है कहीं पे भी जीरो कर सकते हैं पोटेंशियल. ठीक है ना, ग्राउंडेड
sir.
कंडक्टर है कहीं पे भी पोटेंशियल जीरो कर सकते हैं. क्लियर?
Yes,
Q1 बाई ए पॉजिटिव पोटेंशियल हो गया और यहाँ पे माइनस Q2 चार्ज है तो माइनस Q2 बाई आर नेगेटिव पोटेंशियल हो गया और जुड़ के जीरो आ रहा है, तो यही इक्वेशन आएगा. Okay, so let's try to solve a couple of questions based on this idea. Suppose if I give you a setup जहाँ पर charge of the particle is 24 whatever nanocoulombs and at a distance from the charged particle we place a grounded sphere, grounded conductor, and I ask you what is the ये distance system कर लो some 48 centimeters etc. and you have to find me out what is the charge induced at this point. sigma induced at this point. Assume sphere ka radius is 12 centimeters. Okay, and this distance is 48 centimeters. This also. Problems on that?
Yes,
You
sir.
have to find out the charge induced at that point. Induced charge density at that point. ये आइडिया ग्राउंडेड स्फीयर के लिए है, बट इसको अभी तक जनरलाइज नहीं किया पर why is it for a grounded sphere? Because we calculated the equation of a equipotential surface whose potential was 0. Are you clear with this, everyone?
Yes, sir.
We this equation,
Yes, sir.
इसको जनरलाइज मत कर लेना कि ये कोई भी स्फीयर और कंडक्टर चार्ज पार्टिकल है तो ये चीज यूज करेंगे. ये कब यूज करेंगे? when the conductor is grounded. Please go through it. I give you 2 minutes. Just a moment. I'll come back. Yes, done. Do you understand this much that there'll be different charges induced? Charge density uniform नहीं होगा यहाँ पे, है ना? यहाँ पे सबसे ज़्यादा negative charge and then so on and so forth. Decrease as we move ahead. अगर एक यूनिफॉर्म एक्सटर्नल फील्ड होता तब अपने को पता था क्या चार्ज डिस्ट्रीब्यूशन है ना. For a uniform electric field, we could have still figured out what would be the charge distribution. But यहाँ पर how do you find out?
Sir, E resultant निकालना पड़ेगा.
Yes, we'll have to find out the resultant electric field due to what? Due to this charge and its image.
And Q2.
Conducting sphere का image, right? What will be the conducting sphere ka image? It will be a charge minus Q2. At what distance will I have to place the charge and how much will be that charge? ये वाला distance B can be written as what?
3.
R squared by A, R का value 12 है, so 12 squared by 48. क्या आ रहा है? करो please.
3 centimeters.
3 आ रहा है. Okay, 3 centimeters.
3.
And how much is that charge Q2 that I have to place?
6.
6 nanocoulombs, minus 6 nanocoulombs in polarity. Okay. So now I have to find out the resultant electric field at this point. The resultant electric field इसके लिए rightwards. For the negative charge also it will be rightwards. So the resultant field will be additive at point P. Go through it please. E due to the charge 1 plus E due to the charge 2. Okay, so this will be K into 24 by R square. R is how much? R is 36.
Yes.
Yes, 36 square. वो सब orders of magnitude you can adjust. Okay, plus K into the charge Q. E2 is the charge Q2 will be 6.
6.
By R over here will be 9 square. Oh. नैनो कूलम में तो 10⁻⁹ आएगा वहां पे, और डिस्टेंस को सेंटीमीटर से मीटर में कन्वर्ट किए तो और एक 10⁻⁴ आ जाएगा, राइट? तो 10⁻⁵ आई थिंक will be the factor. Please go through it. Calculate करो क्या आ रहा है, the resultant field. Because this resultant field will give you the answer.
So k के साथ
नहीं, k को हटा दो ना, 9.9, बिकॉज नीचे में सब 9 वाले टर्म्स ही है ना, तो 9 10.9 वाले टर्म्स कैंसिल ऑफ हो जाएंगे।
नहीं तो अगर हमें सिग्मा निकालना है तो एप्सिलॉन नॉट हटा देते
हाँ, वापस से एप्सिलॉन नॉट, हाँ यस यस, दैट्स करेक्ट, k के साथ ही लिखना वुड बी बेटर। सो इट बी 30, नहीं 30 नहीं, 4 स्क्वायर आएगा, 4 स्क्वायर वुड बी 16 and 6 96, and 24 will be 120. 120 into k into 10 to the minus 5 by 36 squared. I think this is what you get. And so this resultant electric field will be written as sigma induced by epsilon naught. Outside a conductor, the field is always sigma by epsilon naught. This is an important result to remember. And so sigma will can be calculated from this. क्या आ रहा है value? If someone can check. Solve हो जाएगा ना यहाँ से?
Yes.
k को 1/4 pi epsilon naught लिखेंगे और epsilon naught will cancel off. So there will be a 1/4 pi term as well. Okay, so 120 by 4 pi into 36 squared into 10 to the minus 5, maybe something like this, coulombs per meter square. Now what would happen if we do not ground the sphere? अगर sphere grounded नहीं है तो फिर क्या होगा?
नेट चार्ज इनिशियली 0 था तो नेट चार्ज 0 होगा।
नेट चार्ज 0 होगा। हाँ नहीं, वो
सर
ठीक है,
इनिशियली 0 था।
वो ठीक है। I mean, how would you approach such problems? This idea that we discussed is only valid for problems where the conductor is grounded. This formula that we have found is valid for grounded conductors. If the conductor is not grounded, then how do you approach? समझते हैं? Suppose there is a charge Q and there is this sphere which is not grounded. So abhi, what can I say? I can say that if there is there is some charge Q on this sphere, then that will be uniformly distributed in absence of this charge particle. So Q2 या कुछ मान ले, या Q3 assume कर लेते हैं, ये Q1 assume करें, and let's assume this is charge Q3. Okay, so this will have a uniform charge distribution. So sigma would be given as what? Sigma would be given as Q3 by 4 pi r square. Yes.
yes sir.
और अगर न्यूट्रल कंडक्टर बनाना है तो मेरे को Q3 को किसके बराबर रखना होगा?
0.
अगर that has to be Q2, right? The second charge. Q3 is the charge over here, that if I assume that the charge is Q3 and if there is no charge particle over here, then this is how Q3 would have reoriented itself. On this now I have to superimpose another charge distribution because of the charge Q2, right? And if I want the net charge to be 0, then Q2 and Q3 must be equal. देखो समझ में आ रहा है या नहीं? एक Q3 charge भी और consider करना होगा, and that Q3 charge must be equal to the Q2 charge in magnitude. Only then they will cancel off and the net charge will be 0.
सर नहीं समझ में आ रहा.
If the
तो ये
conductor
थ्री
is,
सिस्टम हो गया.
yes, it is a 3-charge system, exactly. If the conductor is neutral and not ground, okay, then if you have to find out how the charges rearrange on it, I can think of it as 3 charge particles. इस पे charge Q2 और Q3 तो हो गई, Q2 जो अभी डिस्कस किए, एंड Q3 अगर इसमें खुद में कुछ अगर चार्ज होता तो वो यूनिफॉर्मली डिस्ट्रीब्यूट होता, राइट? आर यू एबल टू अंडरस्टैंड दिस? आई डोंट नो.
सर ये तो पॉजिटिवली चार्ज या पे न्यूट्रल कैसे?
नहीं, अगर मेरे को इसको न्यूट्रल करना है, वही मैं बोल रहा हूँ, इफ आई वांट दिस कंडक्टर टू बी इलेक्ट्रिकली न्यूट्रल, Q3 and Q2 must cancel off each other. The net charge on the conductor must be Q3 minus Q2, must be 0. ठीक है, तो मुझे यहाँ पर एक स्फीयर, मैंने instead of the conducting sphere with a uniform charge density Q3, I'll have to place a charged particle at the center. With what charge? What is this charge Q over here? Q3 का value can be written as
प्लस Q2.
R by A into Q जो लिख रहे थे इतनी देर से. एक चार्ज रखना होगा जो इंड्यूस चार्ज के कारण हो रहा था जब कंडक्टर को ग्राउंड कर रहे थे, दैट वाज नेगेटिव ऑफ दिस वैल्यू. माइनस R by A into Q, और एक तो जो असली चार्ज Q है. You'll have to solve it as a 3 charge particle का प्रॉब्लम. दिमाग घूम गया सर आज. देखो विजुअलाइज करो, ट्राई करो, प्लीज ट्राई टू थिंक ऑन इट. I want net charge of this on this conductor to be 0. It's a neutral conductor, right? I've removed the ground, so net charge of this conductor will be 0. If the net charge has to be 0, how much charge on this conductor should be extra? अगर grounded करते तो minus Q2 charge इस पे आ जाता. अब इसको ground नहीं करते तो I want to give a charge on it Q3, which is how much? Which is in magnitude equal to Q2. तभी तो ये न्यूट्रल होगा ना, तभी तो नेट चार्ज यहाँ पे 0 होगा.
Yes,
Yes or no?
sir.
अब
Yes, sir, yes,
if
sir.
I just think that this is a charge Q2, माने ये पॉजिटिव चार्ज सिर्फ होता तो वो यूनिफॉर्मली डिस्ट्रीब्यूट करता अपने आप. In absence of Q1 and in absence of this Q2, the charge Q3 would have done what? Uniformly distributed itself around. Okay, so if it is a uniform distribution, तो इसका इमेज कहाँ होता है? इसका इमेज यहाँ पे होता है, सेंटर पर. I could have replaced this conductor with a uniformly charged distribution at the center. Okay, and because of the charge that I have placed, I get an image because of the induced charges. So the net charge distribution of this conductor will be what? The net charge distribution of this conductor will be the non-uniform negative charge distribution. Non-uniform negative charge distribution that I have. What else?
Positive of Q.
A uniform positive charge distribution. A uniform positive charge distribution. Non-uniform distribution of minus Q2, uniform distribution of plus Q2. ये non-uniform distribution आया इस चार्ज के कारण, ये plus Q1 चार्ज के कारण. So we have to solve it as a problem of 3 charge particles. Problem on neutral conductors, okay, which are not grounded. Neutral conductor का problem, you will have to solve it in this one. As
हम यूनिफॉर्म इसलिए कर पा रहे क्योंकि नेट पोटेंशियल यहाँ पर 0 है.
sorry.
Q3 का यूनिफॉर्म डिस्ट्रीब्यूशन
नेट पोटेंशियल 0 है कंडक्टर का।
बाई Q1 एंड Q2, मतलब नहीं, मैं वैसे बोला हूँ कि Q1 और Q2 की वजह से, क्योंकि कंडक्टर पे पोटेंशियल 0 है, इसलिए Q3
Yes.
वो होगा यूनिफॉर्म।
हाँ, नेट पोटेंशियल 0 है ना, तो बस अब एक उन दोनों चार्ज को भूल जाओ, Q1 और माइनस Q2 को, जस्ट सोचो Q3 है अगर, तो वो यूनिफॉर्मली डिस्ट्रीब्यूट होता।
ओके सर।
If Q1 and Q2 are Q1 and minus Q2 are because of each other, because of Q1 minus Q2 appeared on that grounded conductor. If I remove the grounding, if I remove the charge Q2 and Q1 and I just place Q3, it will obviously get uniformly distributed.
यस सर।
Okay. इस कंडक्टर के ऊपर रिजल्टेंट इलेक्ट्रिक फील्ड इनसाइड तो जीरो ही होना चाहिए। द रिजल्टेंट इलेक्ट्रिक फील्ड इनसाइड द कंडक्टर शुड बी जीरो इवन आफ्टर अगर मैं ग्राउंडिंग हटा देता हूँ तो भी तो अंदर में तो इलेक्ट्रिक फील्ड जीरो ही होगा। सो यू विल हैव टू थिंक ऑफ इट एज अ 3 चार्ज पार्टिकल सिस्टम। फॉर न्यूट्रल कंडक्टर्स you have to treat it as a 3 charge particle system. थोड़ा सा ये might take some time to digest. थोड़ा सा अगर सोचोगे तो it will become evident, it will become obvious. Problems on neutral conductor in front of a charge particle in front of a neutral conductor, charge particle in front of a neutral conductor has to be solved as a 3 charge particle system. एक जो खुद चार्ज पार्टिकल रखे, एक ये नेगेटिव चार्ज जो इंड्यूस हो रहा है, राइट, ग्राउंडेड कंडक्टर के केस में, and because the conductor is not grounded, I have to place the same amount of positive charge on it. I have to place the same amount of positive charge and I have to place it at the center. I'll have to place it at the center. So at the center that charge is to be placed. Your distance is the same distance b. Go through it, please. Same formulas are now applicable. B is r squared by a and so on. A is the distance, A is this distance, I think. Same formulas are applicable. B is r squared by a and Q is r by a, या फिर Q2 is r by a into Q. Go through it, please.
यस सर।
So at your level, you just need to remember these 2 rules if you want. That if there is a neutral conductor, I'll just replace it by a minus Q2 charge. If there is a grounded conductor, I'll replace it by a minus Q2 charge. If there is a neutral conductor, I will replace it by 2 charges. What 2 charges? Minus Q2 and plus Q2. Okay, let me just summarize it. The result that you have to remember. There are just 2 cases that we have discussed. One was a grounded conductor. If there's a charge Q and there's a grounded conductor at a distance a away, then how do you solve this problem? You'll solve this problem like this. You'll have to place a charge Q dashed, which is what? Minus R by A into Q. At what distance will you place this?
A
R square by
At a distance
from the center.
B, which is R squared by A from the center. This is one case. And what is the second case? The second case is if it is a neutral conductor. If it is a neutral conductor in front of a charged particle, same A distance away, then how do you solve problems based on this? You will replace them by 3 charges. A Q, एक minus Q dashed और एक plus Q dashed. Same distance B2. B is R squared by A This is still the center of the circle, center of the conductor, and Q dash is still R by U into Q. Please go through. Solve करें, problem solve करना है कि give up हो चुका है?
Yes.
Yes.
Try करो. Let's assume that there is a conductor, maybe a neutral conductor. And there's a ring, charged ring, concentric ring, of radius 5r maybe. इसको 2r मान लो और ये sphere का radius r शुरू करो. And you have to find me out the potential at a distance p, which is 4r or 5r or whatever. So, I hope I'm clear with the problem. The sphere is of radius r, the ring is of radius 2r, and you have to find the potential at a distance 5. न्यूट्रल कंडक्टर को कैसे डील करने अपन करना सीखे अभी कुछ देर पहले. Neutral conductor and a charged particle. You just learned how to deal with it. The neutral conductor can be replaced. मैं just एक छोटा सा charge assume करता हूँ यहाँ पे. I'm just taking a dq charge over here. What will I do? What will be the image of this dq charge? So to say, the neutral conductor, I'm so sorry, not neutral. The grounded conductor can be replaced by what? Can be
minus q
replaced
by
by
Minus d.
a minus dq by 2 charge. Excellent. The neutral conductor for that charge dq, okay, उसका image so to say मैं निकालने की कोशिश कर रहा हूँ, will be minus r by ये distance is 2a, 2r into q. So I can say that dq dash is minus dq by 2. And how far should I place it from the center of this conductor? Sorry.
R by 2.
ये length x निकाल रहे हैं sort of. So that x can be written as क्या formula है इसका? R squared by ये ना. So r squared by 2r. So that is r by 2. So for this dq charge, I have to place a minus dq by 2 charge at a distance r by 2 from the center of the grounded conductor. I will do the same for what?
All dq charges.
Yes. And so what will I get?
A ring
Yes,
Ring.
a ring of what radius?
R by
R by
2.
2.
of r by 2
And what charge?
Q by 2.
minus q
Minus
by
Q by
2.
2.
बस हो गया, solve कर लो problem. दो ring का potential निकालो. Minus q by 2, r by 2 एक ring है और दूसरा ring जो है वो q and 2r. And potential has to be found at a distance, whatever, 5 or whatever. निकल जाएगा ना? हेलो,
यस सर।
Yes, sir.
हाँ
ये
Yes, sir.
पोटेंशियल ड्यू टू द पॉजिटिव रिंग एंड द नेगेटिव रिंग, KQ by R square X square, वो सब जो फॉर्मूला था लगा, समझ आया?
Yes, sir.
Sir.
So this is the summary of इतना जो ज्ञान में जो दिया उसका summary इतना है। उसको समझ के याद करो या ऐसे याद करो, जैसा भी करो। Can we move forward?
Yes.
यस सर।
Okay, great. I think we have time. थोड़ा कुछ एक और problems कर सकते हैं। Okay, let's do a bit of mechanics now. Two blocks of mass m each, spring constant k, and उसका natural length L है. What is the frequency of oscillation?
वन बाई टू बाई
1/2 k by
रूट
Time.
टू के बाई एम।
टाइम पीरियड का फॉर्मूला इज 2 पाई रूट m by k होता है, तो यहाँ पे m की जगह म्यू लिखेंगे by k. I hope you know this. If there would have been multiple springs, then I would have written k eq also. Okay. Where mu is the reduced mass, in this case the reduced mass would be m by 2. Yes or no?
यस सर।
And
Yes,
frequency
sir.
f1 will be 1 by 2. Okay. Whatever it is, you can calculate the expression. Now what I do is I place charges on the two blocks. Like charges place किए तो उसके कारण रिपल्शन हुआ तो स्प्रिंग इलोंगेट हो गया एंड वापस से इक्विलिब्रियम आया 12. इसका कुछ फ्रीक्वेंसी f2 है. I want you to find out f1 by f2 condition. That is all I need.
सर
Yes, please.
आ तो बन ही रहा है।
नहीं, मेरे ख्याल से तो ज्यादा आना चाहिए, मतलब f2 का फ्रीक्वेंसी, f2 I think should be more, I think. सेम आ रहा है क्या फ्रीक्वेंसी तरह?
सर वो बात नहीं है, वो बात ये कि अगर इलेक्ट्रिक फोर्स में डिफरेंस आएगा वो तो नीचे आएगा 12 प्लस एक्स में आएगा।
हाँ हाँ हाँ, तो उसका तो बाइनोमियल एक्सपेंशन करना है ऑब्वियसली, वो तो
हाँ।
बाइनोमियल एक्सपेंशन करोगे तो वो तो स्टैंडर्ड चीज है. Okay. Okay, let me try to solve this maybe. I can say that kq squared by 4l square is the electric repulsion, and that will be equal to k into l. Okay. Let's not get confused between these two k's. Let's write it as small k. Okay. So this is one equation. When I displace it further by a distance x, then we can say that the spring force will further increase and the electrostatic force will further decrease. This is Fe and this is Fsp. And so the net force can be found in this case as what? K into L plus X plus of the electrostatic force, which is K into Q squared by R is 2L plus X whole squared.
नेगेटिव होगा ना, तभी तो F
Obviously,
0 होगा.
negative. Yeah, of course. Minus sign आएगा. See if you are clear with this. If I displace it by X, then this is the spring force, this is the electrostatic force. And so I can write it as K into L plus X. And this can be approximated as, written the same. Sorry. So this is minus KQ squared by 4L squared, 1 plus X by 2L to the minus 2. This is a standard binomial expansion approximation that we do, right? We assume X is very small as compared to L, etc. Right? You know the story. So 1 plus X power n is 1 plus nx. And so this will come out as what? ये वाला term cancel off हो जा रहा है ना? KQ square by 4L square and KL will get cancelled out.
Yes, sir.
Yes.
And I'll be left with a KX over here and minus of KQ squared by 4L squared X by L.
प्लस हो जाएगा.
Plus हो जाएगा. Minus into
Plus हो
minus will
जाएगा.
become plus. Yes. 1 plus X power n is 1 minus nx. Okay, I hope you know this. 1 plus X to the power minus n is 1 minus nx. That's the binomial expansion approximation that we use. We ignore the higher powers because X is very small as compared to it. And so this can be written as K. So another K will KX will come up. So this is 2KX. Please go through. Clear है?
Yes, sir.
Yes, sir.
Yes.
So now you can solve, right? यहाँ पर the net force was just kx. यहाँ पर the net force was just kx. यहाँ पर the net force is 2kx. अभी जो problem अभी जो पूछा you can solve. You can be asked various questions. You can be asked that both the blocks are free to move. You can be asked that one body is fixed and the other body is free to move. Then it will not be remain a reduced mass system anymore. अगर एक को fix कर देते और सिर्फ एक को ही free रखते हैं, if it is fixed free, then it is not a reduced mass system.
M हो जाएगा.
Same हो जाएगा मतलब.
सर मतलब सिर्फ M रह जाएगा, M by 2 नहीं रहेगा.
हाँ, m हो जाएगा, m की जगह m by 2 की जगह. And if both are free, then it will become a reduced mass. Right. Mu in general is given as m1 m2 by m2. And time period is 2 pi root mu by k. If one body becomes fixed, then I can say कि उसका mass is very large as compared to the other. That is not moving. Only the other guy is just oscillating, and so in that case, mu becomes equal to m2. Please go through. If doubts, please ask. Or else we can move forward.
सर मेरे पास एक इलेक्ट्रिक का क्वेश्चन है, लाइक
फॉरवर्ड कर दो,
इलेक्ट्रोस्टैटिक्स का वो भेजूं?
फॉरवर्ड कर दो व्हाट्सएप में। Fine. Next question. Let's assume that there is a block and there's a plank. Block is of mass m, plank is of mass capital M, spring is of constant k. They are at a height h apart. The block is released. You have to find out, the amplitude of oscillation. It is said that the block sticks to the pan after it strikes. The block sticks to the pan after collision. Find the amplitude of oscillation. Time period of oscillation अगर पूछता तो क्या आंसर होता?
2/√2m/k.
root m plus m by
m plus m हो जाता है, 2/√m plus m by k. So that is not needed. Amplitude of oscillation होता है. आज में तो मेंस का भी रिजल्ट है, आ गया क्या ऑलरेडी कि नहीं आया? करोड़ों बार
4 दिन
मेंस दे चुके
से
हैं,
आ ही रहा है वो।
करोड़ों बार मेंस दे
सर अभी
चुके
तक लिंक नहीं आया है रिजल्ट देखने
हैं।
का।
बहुत बढ़िया।
4 दिन से वो आ रहा है।
4
एडवांस की
दिन से
रजिस्ट्रेशन आके
4 दिन से रिजल्ट आ रहा है, 4 बार मेंस हो गया, मतलब कुछ भी हुआ है बैच के साथ में इसका। एनीवेज, पीस आउट। Initially is the spring compressed या no, या natural length पे?
सर
Obviously ये compressed configuration में
Compressed.
है ना? This is not in the natural length position, it's already in a compressed position. This must have been the natural length, and this is the equilibrium position as of now, which is mg, capital Mg by k. But once the block comes and hits, then the equilibrium position itself will shift, and this would be the new equilibrium position after the block 2 comes, and that will be given as small mg plus capital Mg by k. ठीक है, तो यहाँ से फर्दर वो कितना जा रहा है, दैट विल बी द एम्पलीट्यूड. दिस इज द एम्पलीट्यूड. देखो ये समझ में आ रहा है?
यस सर।
How do I solve this then? How much is the amplitude? That's the question.
सर पूरा एनर्जी कंजर्वेशन से यूज कर सकते हैं सर। नेट टोटल कॉम्प्रेशन इज स्टोर्ड एज एसपी।
एक और
सर लॉस
ब्लॉक कोलिजन में तो एनर्जी लॉस हो गया.
से अपने वो भी कर सकते हैं कि मोमेंटम कंजर्वेशन करके,
हाँ, पहले तो मोमेंटम कंजर्व करेंगे, वहां से वेलोसिटी आ गया
तो फिर उसमें
m into root 2 gh.
ओमेगा इनटू रूट ए स्क्वायर माइनस एक्स।
हाँ, yes, that is what I wanted. m into root 2 gh divided by n plus m is the velocity. at this position. जब ब्लॉक आगे स्टिक करके दोनों एक साथ मूव करने लग गए, then this is the velocity will be start. Okay. Now from the equilibrium position, we know that it is what distance away above the equilibrium position.
Small mg by k.
So this will be small mg by k. Now since it is an SHM, this equation would be valid. V equals to omega root over of a square minus x square. V यहाँ पे अपने को पता है, ओमेगा ऑफ द सिस्टम अभी मैं लिख दिया यहाँ पर, राइट, रूट ओवर ऑफ k by m plus m. Amplitude is what I have to calculate, and x I have just found is mg by k. ऐसा होना. स्टैंडर्ड तरीका ये नहीं है. स्टैंडर्ड तरीका है कि एनर्जी का पहले मोमेंटम कंजर्व करके वेलोसिटी निकाल लिए. अब यहाँ पे एनर्जी इक्वेशन लिखेंगे कि हाफ m plus m into the velocity that I have found squared. Okay, this is the energy over here, and at the lowest point there is a loss in potential energy, so that will also get added up to this. There's also some spring energy over here, half k mg by capital mg by k whole squared, and there will be some potential energy, gravitational potential energy, that will get added on the system. That will be small m plus capital M into g into h. H will be how much? This will be h. A plus
mg by k.
mg by k, small mg by k. This is the loss in this is the total potential energy that it will जो फाइनली हो जाएगा. फाइनली क्या एक्सप्रेशन लिखेंगे बताओ? हाफ k into what?
m plus m into g.
Half k into a plus the equilibrium compression m plus mg by k का होल स्क्वायर. ये एक्सप्रेशन होगा और यहाँ से ये आएगा, which is a lot of work. Since it is an SHM, I can use the formula V equals to omega root over of a square minus x square directly. And we know the velocity at that x. X is the distance from the mean position. The new mean position has shifted down. वो initial mean position था, तो उसके बीच का distance is small mg by k. समझ में आया?
Yes.
Yes, sir.
So you can use the energy equation after momentum conservation. Directly energy नहीं use कर सकते कि mg is equals to this. But after you have conserved momentum, then you can use energy and find the amplitude. But this is obviously better. Please remember this method.
सर x में कैपिटल mg होगा ना?
Small x में. Small x में तो small mg होगा ना. नया उसका जो you know the new equilibrium position, उससे क्या दूरी है?
वेलोसिटी भी तो फर्स्ट इक्विलिब्रियम पोजीशन पे है.
नहीं सुन रहा यार, तेरा आवाज काफी डिस्टर्बेंस हो रहा है.
वेलोसिटी भी तो फर्स्ट इक्विलिब्रियम पोजीशन पे है ना?
V max थोड़ी लिख रहे हैं. This V is the velocity above the equilibrium position. This is the equilibrium position. यहाँ पर V max होगा, but उससे क्या मतलब है?
हम लोग जो v लिखे m रूट टू ch by m plus m, वो इक्विलिब्रियम वन पोजीशन पे है ना?
हाँ, that is the velocity at equilibrium one position after the block collides and it starts moving together.
तो वहां पे x का वैल्यू तो mg by k हुआ, कैपिटल mg.
Compression in the spring is mg by k. ये वाला capital mg by k है. But ये वाला formula में what is small x?
अच्छा,
Small
okay,
x is the
okay, sir.
distance from the equilibrium.
हाँ.
Distance of the block from
ठीक है,
the new
sir.
equilibrium position, which is small mg by k. Okay, let's move forward. इस टाइप का सिमिलर क्वेश्चन अपने किए थे, अगर इफ यू कैन रिकलेक्ट, वी हैड डन अ सिमिलर क्वेश्चन लाइक दिस. याद है? स्प्रिंग एंड स्ट्रिंग था,
Yes, sir.
राइट? एंड अ ब्लॉक, इसलिए नोट्स रिवाइज करना जरूरी है। और इसका टाइम पीरियड पूछा था एक्सेट्रा। इनिशियली इक्विलिब्रियम पोजीशन में है, और अगर इसको डिस्प्लेस कर देंगे by double, it's I can say in equilibrium position k into x naught is equals to mg. So equilibrium x naught is mg by k. So if I give it a displacement which is less than x naught, if the displacement is less than x naught, the spring will not come back to its natural length. ये उसका natural length position था. It has been displaced by x naught already, and it has attained equilibrium. From equilibrium, if I further displace it by a, it will start oscillating about the mean position with an amplitude a. And if this amplitude is less than x naught, I can say that the spring does not reach the natural length position. Spring does not reach natural length. And so the time period will remain 2 pi root m by k. But if I give it a displacement which is, let's say, double this x naught, then there is a problem. Why? Let's say 2x naught. तो जितना नीचे जाएगा उतना ही ऊपर जाने की कोशिश करेगा, बट वो उतना ऊपर जा नहीं पाएगा। भाई उसके पहले क्या हो जाएगा? The spring will come to the natural length, the spring will slacken, and so इधर से इधर तक तो वो SHM किया, बट इसके बाद से वो क्या करेगा? यहाँ पर it will have some velocity left, and so it will be a free fall under gravity, and then again it will do an escape. तो इसका टाइम पीरियड अगर निकालना है तो कैसे निकालेंगे? टाइम पीरियड ऑफ ऑसिलेशन। क्वेश्चन समझ में आया?
Yes, sir.
So how do you find it out? Come on. ये और ये तो t/2 तो दिख रहा है. This and this is t/2. What about the blue part and the orange part?
So वो वाला blue part t/6 होता है.
ऑरेंज पार्ट तो वैसे हो जाएगा 2v is equals to gt से.
Yes.
और ब्लू पार्ट के लिए हम लोग को थीटा वाला करना पड़ेगा सर्कल पे.
So वो t/12 0 से हाफ वाला.
Yes. That is what I. ये तो x0/2 है ना. x0/2 का तो स्टैंडर्ड फॉर्मूला है. कुछ सर्कल वर्कल कुछ नहीं करना है. This is a. This is a/2. This time we know is t/12, right? This is t/6. That adds up to t/4. So I can say that from the mean position, I just have to go up till x0. Okay, I just have to go up till x0. And so how much would that be? That is half of the amplitude 2x0. समझ में आ रहा है? Yes or no?
Yes, sir.
Just a second.
Yes.
Okay, yeah. So I can say that this time is t/2. This time will be t/12 plus t/12. So that will be t/6. And how do you find this time? How much is this time? Please solve.
तो वापस वेलोसिटी को वैसे
Exactly.
लेंगे.
मतलब that is what the connection which I wanted to build. टाइम यहाँ पे 2v/g होगा. फ्री फॉल का टाइम है. v वेलोसिटी से अगर प्रोजेक्ट हुआ पार्टिकल तो v/g plus v/g will be 2v/g. So the total time period, so to say, will be t/6 plus t/2 plus 2v/g, where v over here can be written as omega root over of a squared minus x squared. And how much is x? Mean position say amplitude is 2x0.
x0.
So x0. If you are clear with this. Omega root over of 3 x0 squared by 4. where x naught is mg by k. Are you clear
So
with this?
इसमें तो वो हो गया x नॉट अगर mg by k है तो 3x नॉट स्क्वायर
मैं नहीं समझा.
एम्पलीट्यूड 2x नॉट है
Amplitude is 2x naught, yes. Oh, हाँ, amplitude is
by 4
2x
नहीं
naught.
होगा
Amplitude is 2x naught and x is x naught, yes. So it'll be
So 3x naught.
3x naught square.
3x naught square.
Whatever. You understood the idea, right? So that is what is to be done. Can you move forward?
Yes, sir.
Yes.
If you assume an infinitely long wire having a current I know whatever you call it as, and a charge mass m plus q is given a velocity v naught from a distance x naught, then what will be the minimum distance of approach for the charge particle?
ये वायर फिक्स्ड है या फिर बस रखा हुआ है?
Wire fixed, fixed current wire, of course. What is happening over here? There'll be a magnetic field
not
involved,
uniform
force.
field में हाँ
and because of that, the particle ka path will start changing. It will not remain a straight line. Will it be a circle?
no so ये
It
non
won't be a circle
uniform
either
magnetic
because it is not a uniform magnet, but some curved path for sure. And at some stage, जहाँ पर velocity becomes ऐसा, velocity, the speed will not change because the work done by the magnetic force will be zero. And so eventually the particle ka velocity will become as such. That will be the time when the separation is minimum, right? This is the path of the particle. So यहाँ पर velocity, when the speed becomes in the y direction, purely, that's the time when the separation is minimum, and that is what we have to find. So while I decorate the diagram. क्या करेंगे? At some distance x, if I think the particle has a velocity v naught as such, the magnetic force will be q v cross p. and magnetic field is in the downward direction, and that will be mu naught I by 2 pi x. This is the magnetic force. V cross P, V cross P. And so what do we see over here? That there is a component of velocity along x which is being reduced by the magnetic force ka x component, and there is a component of velocity along y which is being helped by the magnetic force ka y component. And that is how the velocity along y is increasing and velocity along x is decreasing. And finally it becomes v naught in the y direction and vx becomes 0. That's the minimum approach wala field. So if I assume ये वाला angle is theta, थोड़ा सा मैच करना होगा. तो vx is v naught cos theta. And what is ax? Can anyone tell me? Particle का mass m दिया गया है. What is ax?
Now sin theta by
Mhm.
x.
Ax,
Y component of
yeah, y component of velocity will
velocity.
produce fmx. Very good. Please realize the y component of velocity is what produces fmx. Fmx by the mass करना है. Fmx will be produced by the y component. V cross B, अगर Vy cross B करोगे तो leftward rightward force आएगा. And so that will be q Vy into mu naught I naught by 2 pi x. Just check please.
Yes.
And Vy we know is V sin theta यहाँ पर. If that is cos theta, this is V sin theta. What next should we do?
V dv dx यूज कर सकते हैं.
Ax की जगह पर
V dv dx.
ठीक है Vx
So
dvx
Vx into
dx.
d. Yes
Yes.
sir.
Okay. And then
अब बैठ के इक्वेट करेंगे. तो थीटा आएगा तो थीटा 0 to pi by 2 से इंटीग्रेट करेंगे. सम d थीटा आना चाहिए.
Vy है यार
और x
RHS
को
में.
सो वो तो v नॉट sin थीटा हो जाएगा.
ठीक है V
सब
naught sin theta हो
थीटा और
जाएगा.
x के टर्म्स में, सब थीटा x के टर्म्स में ला सकते हैं अपने.
There's a Vx dvx and there is a dx. And there is a new variable
Sir,
theta which has entered.
second now.
सर vx को सर v naught से 0
Sin-
तक इंटीग्रेट.
हाँ v नॉट cos थीटा से तो वो हो जाएगा ना माइनस v नॉट sin थीटा d थीटा.
Vx can be written as minus V naught sin theta d theta.
नहीं सर dvx.
X से डिफरेंशिएट करोगे. ठीक है. तो dvx by dx will be minus V naught sin theta into d theta by dx. ऐसा कुछ.
Yes sir.
ठीक है. तो यहाँ पे सब्स्टिट्यूट कर दें.
हाँ सर
V naught
सब
cos
सब्स्टिट्यूट
theta
कर देंगे.
into minus V naught sin theta d theta dx. That is equals to q Vy. Vy can be written as V sin theta by m and mu naught I naught by 2 pi x. तो आ जाएगा फिर. It's just theta and x now. So now we can get this. Theta will go from 0 to pi by 2 and x will go from x naught to x naught. And so that will get give you the answer. Yes, bro. Hello. Okay. Next. Just solve one last idea and we stop at that. That's 12. If I assume that there is a charge Q1 and there's a charge Q2, what is the force on charge 1 and what is the force on charge 2? Magnitude. R is the separation.
Q1, Q2
Q1, Q2
by
by R.
us.
Sorry, क्या question पूछ रहे हैं? Q1, Q2 by R. Okay. Now, if I displace the charge Q2 by a distance delta R, then what will happen? What will be the force now on charge Q2 and what will be the force now on the charge Q1?
K Q1 Q2 by R minus delta R plus square.
On which charge?
दोनों पे.
both.
हाँ, तो यहीं पे जो मुझे point discuss करना था. Suppose R is very large. If I assume that R is very large, maybe 1 light year away. 1 light year. I hope you understand the distance 1 light year. 3 into 10 power
Yes, sir.
8 into whatever, right?
Yes.
365 into 24 into 60 into 60, right? This many meters. That's the distance. Now, when you shift the charge Q2 by distance delta R, the force on charge Q1 को change होने में थोड़ा time लगेगा. क्यों time लगेगा?
सर इलेक्ट्रिक फील्ड का स्पीड सर लाइट से कम है तो फिर
Yes.
नहीं सर
so
लाइट स्पीड है
the
तो थोड़ा
information,
टाइम लगेगा.
yes, the information that the charge Q2 has displaced will reach Q1 at what time?
In
1
1 year.
year.
साल भर बाद पहुंचेगा वो information, right? It is 1 light year away, and so the information that the charge Q2 has been displaced will not reach Q1 immediately. So if this was the force at time t equal to 0, let's say, then the force at times t equal to 0 plus F1 will be given as Q1 Q2 by R square. What about the force on 2?
सर R minus
R
delta.
minus delta.
Yes, now this is R minus delta R. Why?
इसको पता है ये displacement.
इसको पता है ये displace हुआ है. See, the
नहीं.
idea is that the electric field of the charge Q1 is already established, and that is not changing, right? Electric field of the charge Q1 does not change. Electric field of the charge Q1 is established and it does not change, and so the force on 2 can be just written as Q2 into E1, and E1 is KQ1 by R minus delta R square. So F2 changes immediately, but F1 will not change because the information of the change in F1, the change in position of Q2 will take 1 year to reach Q1. And so उस एक साल तक Newton law would not remain valid. The forces would be unequal, right? So these asymmetries in the system is brought in when we have these fields, right? When there are electric and magnetic fields, this asymmetry can be observed. Generally, अपने बात करते हैं normal level पे, we say that the distance r is very small and the information will travel with the speed of light, and so it will almost instantaneously reach. But this is what will happen actually, that the information will take some time to reach, and उस समय तक वो force F1 change नहीं करेगा. So during that 1 year period, F1 and F2 would not be same, which is not a very obvious thing to digest. Right? Mod of F1 and F2 will not be same. The Newton's third law will not hold true. ये सिर्फ ऐसा नहीं है कि यहाँ पर एक यूनिक केस है. Do not think कि ये कुछ यूनिक सा हो गया यहाँ पर तो इसलिए. This is a very common observation in fields. Okay, in electromagnetic field, this is a common observation that the Newton's law does not seem to hold true. If I have to give you another example, let's see if I can. Suppose there's a charge Q1 moving with a velocity v1. I hope this example works. And this is Let me just check. ऐसा assume करते हैं. Tell me the force on 1 due to 2 and vice versa. F1 और F2 बताओ मुझे. प्रॉब्लम समझ में आया ना, ये क्या प्रॉब्लम है?
F1 तो सिर्फ F ही होगा कि Q1 Q2 बायस
मैग्नेटिक फोर्स, इलेक्ट्रिक फोर्स दोनों पे सेम है, उससे मतलब ही नहीं है. मैग्नेटिक फोर्स
तो मैग्नेटिक फोर्स Q1 पे तो 0 है.
Q1 के लिए 0. Why? Because this is a current element. Okay, IDL is nothing but Q into V. Okay. Current element vector can be replaced as Q into V, right? I hope you know this. dq into V, to be more precise. Current is dq by dt and dl by dt will become V. And so current element can be thought of as moving charge. A current element is nothing but a moving charge. So I can say that since this current element vector and the charge part, the magnetic field on an axial point will be 0. Because of this current element vector, magnetic field will be 0. Why? Because the formula for magnetic field in your Gauss law, in your Biot-Savart's law says mu0 by 4 pi IDL cross R by mod R cube, right? And so since IDL and R vector are in the same direction, so यहाँ पर magnetic field will be 0. And so the force will be 0. What about the force on the particle 2?
Mu0
This will
Q1
be having a
Q2
magnetic
V1
field.
V2.
Magnetic field यहाँ पे क्या होगा? IDL अगर करते हैं तो mu0 by 4 pi IDL can be written as Q1 V1 by R square. देखो ये समझ में आया या नहीं? This is the magnetic field produced by 1 at the point 2, and F2 will be what? Q2 V2 into V1, and this magnetic field is in the inward direction. Please realize this. So this force is non-zero. तो अब अगर मैं ये सोचने लग जाऊं कि भाई दो चार्ज पार्टिकल है, इक्वल ऑपोजिट फोर्स एक्सर्ट करना चाहिए, तब तो आंसर नहीं आता. Do you get that? Hello.
Yes, sir.
Yes, sir.
तो ऐसा नहीं करना है फील्ड्स वगैरह के केस में, इलेक्ट्रिक फील्ड हो या मैग्नेटिक फील्ड हो, उसके केस में आंख बंद करके न्यूटन लॉ नहीं अप्लाई करना है. जिस चार्ज पे फोर्स पूछा है उसी चार्ज का फोर्स माने उस चार्ज पे ही इक्वेशन लिख के कैलकुलेट करना है. We cannot play the trick that I found the force on the other body which was easier and then I said that by Newton's law the force will be equal and opposite on the first body. Okay, so just remember this rule that when we are dealing with force fields, right, force in case of electric or magnetic fields, we must try to find out the force on that body and not on the other body. It might happen that the forces are not equal. Okay. Why of it? Let's not go into that. I mean, electromagnetic fields have their own momentum, they have their own energy, and so it is a lot more conceptual stuff which is not needed at your JEE level. Okay, so let's not go into that. This much I think would be a good idea. The forces might not be equal. Clear?
Yes, sir.
Yes, sir.
Fine. I think this is a good place to stop. We will continue with these revision sessions, right? I will upload this on your. I'll upload the PDF, right? The screenshots I'll upload so that you can refer them if you need to. And we'll have another session this week. Maybe today is Wednesday. Your advanced is on
3rd October.
3rd October.
3rd October.
So we have 15 days. So we try to have a few sessions. I'll let you know on WhatsApp, right? We'll try to have a session this week. So we'll try to have a couple of sessions every week at least for physics, that is, and chemistry, math also. The timing will be timing. Okay, fine. Let's stop at this. See you. Keep working. Bye bye.
Bye, sir.
Bye, sir.
Bye, sir.
Bye, sir.